Hi, my name is Swaksha Mehta, and today we're going to be doing a floating ping pong experiment. So let's get started. For this experiment, you're going to need a plastic water bottle, a straw, some tape, some scissors, and a ping pong ball. First thing you're going to do for this experiment is grab your plastic water bottle and cut off the tag that surrounds it. This experiment is great for the environment because you're reusing plastic water bottles. This part is optional, but you can go ahead and grab some tape and wrap it around the bottle so that it gives you a straight edge to cut against. This is what it should look like after you're done wrapping your tape. Now you're ready to start cutting. You can ask an adult for help, but this is what it should look like after you're done cutting the water bottle. Let's move on to the next step of this experiment. You're going to grab your water bottle cap and place it on a soft surface. Then you're going to grab a pencil and try and poke a hole through the water bottle cap, like so. Now, go ahead and take your water bottle cap that has a hole poked through it and screw it back onto your water bottle. It should look something like this when you're done. We're almost ready to test our experiment. You're going to grab your straw and bend it so that the shortest side can fit inside the hole of the water bottle, like so. Now let's start testing. You're going to blow into the straw so that the ping pong ball starts floating up in the air, like so. Isn't this experiment so cool? You can make 2 of these and have a contest with your siblings or your friends to see who can keep the ball in the air for longer. Let's talk about the science behind this experiment. The floating ping pong ball is a wonderful example of Bernoulli's principle. It's the same principle that allows objects that are heavier than air to fly, like airplanes or rockets. The air from the straw produces the levitating ball effect, as you observed in the experiment. The fast air moving through the straw is much stronger than the air present in the atmosphere, and if you look close enough, the ball wobbles while it's floating in the air because it's attempting to leave the area of low pressure. So the main idea of this experiment is that the air that you blow through the straw is much stronger than the air already present. This causes the ball to start floating in mid-air. Isn't that so cool?
Hi everyone, my name is Ramesh Alkar and welcome back to Club Phoenix. Today we're going to be doing a really cool experiment with antacid tablets and then relating it back to surface area to volume ratio. Hope you enjoy! So, for today's experiment, you will be needing 4 symmetrical cups, 2 antacid tablets, and food coloring. If you don't have food coloring, that's completely okay. I am personally using frosting. Please note that you should not be eating any of the elements from this experiment after using them. Thank you. Okay, so let's get started with our experiment. First, what I'm going to need you to do is take 2 cups that are identical and put the same amount of water in them. Make sure to fill them relatively halfway. Next, what I'm going to need you to do is add a drop of food coloring in there. Now, I personally don't own food coloring, which is why I will be using a little bit of frosting. But if you own food coloring, then that is definitely way more recommended. Now I'm just stirring in my frosting. As you can see, this might be a bit of a tiring process, so you can either try to melt the frosting in there or you can just leave it be a little bit. As you can see, my water has now turned this minty color, so now let's just put that to the side. Next, what I want you to do is take 2 symmetrical empty cups and then take 2 antacids. Just take the first antacid and place it in the cup. Now the second one, I want you to do something different. I want you to break it into as many pieces as possible. Or if you want, you can even use something to help mash it. So for example, I will be using this. As you can see, I have now crushed my other tablet, and now I would just like you to place all of that right into the second empty cup. Now we're going to do something interesting here. We are going to take the colored water and we're going to pour in at the same time. So I am not 100% sure if you can all see this, but what's really interesting is that this one fizzed up a lot faster than this one. This is the one that has the crushed antacid in it, and this is the one that has the full antacid in it. So let me give you guys a more close up. Here's a close-up of both the cups. This one has the full tablet and this one has the crushed up tablet. What's really interesting about this one is that you can clearly see that it is way more fizzy than this one. Any guesses towards why that is? The reason why this cup fizzed up more than this cup is because it has a greater surface area to volume ratio. Now let's talk about what that is. For the same amount of the antacid, the crushed tablet has more surface because there's a lot more smaller pieces of it. And as we know from our previous surface area videos, anything that is broken up into more pieces has more surface area. So the water basically is given more of a chance to react with the antacid immediately, which is why more fizzing happens over here. Thank you so much for joining us, guys. I hope you really had a good time and that you learned a lot. See you next time.
Hey guys, it's Ria, and today we're going to be doing the pencil and bag experiment. It's super fun and easy, and I hope you enjoy it. For this experiment, you're going to need a plastic Ziploc bag, a couple of pencils, and some water. And make sure the pencils are sharpened. To start off, you're going to need to fill your Ziploc bag about halfway with water like this. Then, you're going to take your pencil, and you have to make sure it's sharpened, and you're gently going to carefully stick it into the bag like this. Make sure you don't completely put it through the bag, but just do it like that so it's stuck like that. Isn't that cool? It didn't spill at all. So let's try adding one more. Okay, carefully. Don't do it too hard because otherwise you're going to poke it through too fast and it's going to spill everywhere. Do look at that. One more in. Isn't that so cool? Even if you poke a hole straight through the bag, it doesn't move. And no water comes out. Now you may be wondering how this all works. Well, it's because the Ziploc bag you use is most likely made of low-density polyethylene. The polyethylene molecules are shaped like long strands. So, when the pencil pushes through the bag, it is simply slipping through the strands of the molecules. And because the strands are flexible, they form a temporary seal around the pencil, causing no water to leak out. However, if you take the pencil out, the strands are still pushed aside, allowing for water to spill out. Thank you guys so much for watching, and remember, stay safe and keep learning.